Welcome to this tutorial on basic spreadsheeting. I'll be using the Google Drive Sheets application, but what I go through here will work the same way on Microsoft Excel or any other spreadsheeting program you like to use. So the first thing we need to do is create ourselves a spreadsheet. So with the Drive application, what we say is New Google Sheets. That will make a new spreadsheet for us, which will have no title, so we can click on the untitled spreadsheet and type in, say, My Finances. Now we're going to look at doing a quick savings calculation using compound interest by iteration. So the first thing we need to think about maybe is what sort of interest rate are we going to get from the bank. So we can type in, say, 4.5, and we'll put in our units in the next cell across. So I'm going to put in percent. Now spreadsheets have an interesting way of looking at percentages, and we'll have a look at those in a minute. But for now, let's just do it this way. Then we want to look at our savings over time. So we'll have the time in years here in the first column of our table, and then say we want to look at how much interest we will earn each year and what our closing balance is. Be nice if I could spell. Okay, so we want to start off at 0 years, which is our start point, and then we want to increase our number of years by 1 every time. We could of course just type in 1, 2, 3 on the way down, but we'd like to use the functionality of the spreadsheet to make life a bit easier for us. So we'll use what's called a formula. Now, to tell the computer we're going to do a calculation, we can just type in equals, and that says we're going to make a calculation, and the result of that calculation is what's going to be displayed in the cell rather than the formula we type in itself. So we could type in a simple calculation, say 2 plus 3, for example, and it will put 5 there. But the more interesting calculations we can do use the values of other cells. So at the simplest, we can just say equals and just click on another cell, or type in the reference, and the cell references are a combination of a letter. So in this case, the cell we're in is A6, and the cell I selected by clicking on it is A8. And we can just type those references in, or we can just click the cell and the reference will be put in the formula for us. So if we type in that we want A6 to be equal to whatever is in A8, it will just point at A8. In this case, the value of A8 is 3, so it's made A6 also equal to 3. Now these formulas are recalculated every time you do something to a spreadsheet. So if I put a different value into A8, say 5, we can see that A6 is updated, so it's still equal to A8, and the value is updated to reflect the new value in A8. But of course we don't want the second year to be equal to 5 years, we want it to be one more than the previous cell. So we type in equals to make sure that we can be doing a calculation, and we select the cell above, in this case A5, and then we say we want it to be whatever is in that cell plus 1, because we want to go up by 1 year. And we can see it's correctly calculated that we want to be at 1 year. Now so far we've actually done something that's taken a lot more time than just typing in 1, but where it can save us time is we can copy a formula and paste it into lots and lots of cells at once without having to type it in every time. So you can either select a range of cells by clicking and dragging like this, or what we can do instead is if you are selected one cell, you can hold the shift key down and just use arrow keys to select the area you want. You can select rectangular areas, you don't just have to select columns. For now we just want a column. So I can select that range there, and if we want to copy the formula down, you'll notice we're starting the formula in the top cell is actually the first year, not the 0th year. That's because 0 doesn't have a formula, it's just typed in 0. If we go Control D, it will take the formula or value that's in the top cell and copy it to every single cell all the way down the column, which is much, much quicker than just typing in a whole pile of numbers, particularly if you have very long columns. And if we look at any of these cells, we can see that formula bar up here will show us the formula that's been copied, and we can see that, for example, in A13, the formula says look at cell A12, which in this case is equal to 7, and add 1 to it. And that's where cell A13 is correctly calculating that it wants a value of 8 in there. So the next thing we want to do is then work out, well, how much interest have we earned each year? After 0 years, of course, we haven't earned any interest at all. So let's go across to the balance column. Now in this, because we're looking at the 0 year, this is our opening balance. So let's give ourselves, say, $400. Now spreadsheets will happily handle dollar signs and know that you're talking about money. So we can type in $400 and it will display the dollar for us. We have a balance of $400, so after 1 year we've earned interest on that $400. Now the amount of interest we've earned is equal to the balance multiplied by our interest rate that we're getting. So again, we're looking for a formula. We can type in equals. We select the balance, which is our principal, and we want to multiply it. So we use the asterisk button, which is either above your 8 key or on your numeric keypad, and we multiply it by our interest. Again, we hit enter when we've finished entering our formula. Now in this case, we've calculated a ridiculous interest payment of $1,800, if only it was true. So what's happened here is, instead of being multiplied by 4.5%, we've actually just multiplied by 4.5. So we've got two options. One is the traditional way you will learn in a mathematics classroom, which is to divide by 100 in the formula itself, and that will work. The way that spreadsheets normally work is you effectively divide by 100 in the interest area itself. So let's just Control Z to undo that addition, that change of the formula. Now this time around, I'm going to change the way percent works. So spreadsheets work with percentages natively. So what you can do is you can type in 4.5, and if you type in percent inside that cell, it will know that you're talking about a percentage, and it will store the value internally not as 4.5 but as 0.045. So it will store this small value that you want, which is less than 1, is a fraction of 1. Fraction of 1, it's the number of hundredths of 1, and we can see that our value of the interest calculation is now correct. So in this case, the percent is now calculated, is now displayed inside the cell, so we can delete the additional one over here. So that's just a little trick that spreadsheets will do for you. Some calculators will do the same sort of thing. So if you type in 4.5, there's a percent button, you hit the percent button, and it will often then convert it instantly to 0.045. So now we've calculated our $18 interest correctly. Now we want to add it to our initial balance of $400. So again, we're looking for a formula. We type in equals. We want the previous year's balance, $400. We don't type in 400, we just select the cell that contains the $400. Type in plus and select the amount of interest that we've earned over here. So in this case, we've got a formula that says look at the cell above, which is the previous year's balance, and then add it to this year's interest that we've earned. Hit enter to enter the formula, and you'll see that it's correctly calculated, that we now have $418, $400 that we started with, plus $18 interest that we earned. So as with the time calculation, we can just fill down and copy those two formulas all the way down our table. Again, we can select it using either the mouse cursor click and drag, or just holding down the shift key and using arrow keys to select. We then go Control D, or Apple D in the case of the Mac users. Now we can see we've got ourselves a problem. So what's actually happened here is a problem with references. So let's just have a look at the second cell down, and if we double click it, we can see not only does the formula come up in the formula bar, but any cells that are referenced are highlighted with a coloured outline. In Microsoft Excel, I think it comes up in a solid outline rather than a dotted outline, but the same principle applies. So we can see here that for our second year of interest calculations, it's looking at the amount of money we had at the end of the first year, which is what we wanted. But this time around, instead of looking at our 4.5% we've got up here in cell A1, it's actually looking at A2, which is empty. So we don't want that. What we want is the interest calculation to always look back at exactly cell A1, even when the formula itself is in different located cells. So the way we do that is, instead of using what we've been using so far called a relative reference, so these references always just talk about, go up one and across one, so as you move the formula around, where it looks will also move. We want to use what's called an absolute reference. So this time round, we want C5 to move with the formula. We always want to be looking up one and across one. That's okay. A1, we want to make that one an absolute reference. So the way we do that is we put a $sign before the A and another one before the 1. So that gives us an absolute reference for both row and column. So now if we hit enter, that formula will be unchanged because it was always looking at A1. But when we select all the way down the column and copy the formula down, we'll see our problems go away. And if we look at any of the formulas on the way down the column, let's just pick this one, we can see that the formulas are now correctly looking at the previous year's balance, and they're always going back up here and looking at A1 for the interest rate itself. And we can see that the balance calculation column, if we double click on any of those, they were always only supposed to be using relative references, so all their errors were caused by carrying across the errors that were resulting from our incorrect interest formulas.